Hello everyone, I'm Ashmi Cardenas from ABM11YA4, back again with another video. And you might notice if you've been watching my previous videos that my voice is in a bit of a low register right now since I have gotten into a cold for the past week. I'm sick.
Boo, you whore.
And my voice is like this, but I need to upload a video. So in this video we will be talking about PMF, or probability mass function. So what are we waiting for? Let's get on the lesson. So, what is probability mass function? Well, a probability mass function, or PMF for short, is a function that describes the probability distribution of a discrete random variable. A discrete random variable is one that takes on a countable number of possible values, such as the number of heads obtained when a coin is tossed multiple times, or the number of defects in a batch of products. The PMF of a random variable x is a function that maps each possible value of x to its probability of occurrence. That is, the PMF gives the possibility that the random variable x takes on a specific value. The PMF is defined as b of x is equals to x. Or in other words, let's say, unlike probability distribution where it maps out all the possible occurrence or the probability of it happening, the PMF has a certain event that we are looking for of the probability of it happening. And the PMF satisfy the following properties. The probability of each possible value of x is a non-given, meaning that non-given. It is a non-negative, meaning that everything should be positive. It can't be a negative. The next one is the sum of the possibilities of all possible values of x is equal to 1, which can be denoted as the summation of p of x is equals to x is always equal to 1, where the sum is taken over all possible values of x. The PMF can be used to compute the probability of any event involving x by summing the probabilities of the individual outcomes that make up the event. So, the PMF is an important concept in probability theory, and it is used in many applications, including statistics, engineering, and of course, in our course, finance. So, let us see some examples, or draw up some examples for us to elaborate on what is PMF. So, suppose you have a fair six-sided die. Let x be the random variable representing the number rolled. What is the probability of rolling an even number? What is the probability mass function of x? Well, we are looking for what? The probability of rolling an even number. But first, we need to find the probability mass function of a fair six-sided die, which, as we know, it has 6 sides. So let's represent the first side as 1, then the 2 dots, 3 dots, 4 dots, 5, 5 and 6, right? All of them have the same probability, as they have one side per die. They have one side in the die. So in those 6 sides, we have 1, there's 2, then there's 3 dots, there's 4, and so on and so forth. 6 and 6. So we're going to be looking for the probability of rolling an even number. And all we have the even number is the 2, the 4, and the 6. So what we all need to do is just add all those up. So the bx equals to 6 will be 1/6 plus 1/6 plus 1/6. And our answer will be, since all of this is a similar fraction situation, we will just need to add the numerators. So it will be 3/6 or 1/2 if we simplify it. So our probability of getting an even number will be 1/2. Here is a more clearer view. So the probability mass function of a fair six-sided die is all of them are 1/6, right? And the probability of rolling an even number is the sum of the probabilities of rolling a 2, a 4, and a 6, which we added. 1/6 plus 1/6 plus 1/6 is equals to 3/6, or if we simplified, it will be 1/2 or 50%. So therefore, we will have a 50% chance of rolling an even number. Next, we have another example here. Suppose there are 20 cards in a hat, 5 of which are red and 15 of which are blue. You draw a card from the hat without looking. Let X be the random variable that represents the number of red cards drawn. Well, let's see here. So if we were to say that our sample spaces are red and blue, and we have a range of 0 and 1, since we are looking for whether or not we are going to get a red card. So either we don't get it or we get it. So the 0 can signify blue in this equation. So we can define the probability mass function as Px equal to 0 is equals to, how many blues are there? 15, right? And how many marbles do we have in total? Cards, 20. So 15 over 20 is equals to 0.75 or 1/4, right? And how about if we were to draw a red card, which we will signify as 1. So we have 5 red cards and 20 cards in total. So it's 0.25 or 1/4. Oh, sorry, this will be 3/4. The first one will be 3/4. The one will be 1/4. Yeah, there you go. Okay, so as I've said earlier, that this signifies an important factor of PMF, as if we add both of these two, as I've said earlier, the PMF will always, or the probability of it will always be equal to 1. So 5 times 5 is equals to 10, 1, 13. So our probability is equal to 1, right? But what we are looking for is the probability of drawing red cards. So in this case, as we've seen here, we have 0.75 or a 75% chance of drawing a blue card or not a red card, but we have a 25% chance of drawing a red card. So here is a more clearer view of the example if you don't understand my handwriting. So as you can see here, we have a 75. If we add these two, it will be 1. So as I've said before, signifies the property that we discussed earlier. And as we see here, as we have 20 cards in total and 5 are red, we will just need to divide those to get our percentage of how many red cards the probability of us getting the red card, which is 25%, or in fractions, 1/4. So we have another example here. Suppose a fair coin toss is tossed 3 times. What are the possible outcomes that 2 tails will appear? So our solution here is the probability mass function for a fair coin toss 3 times can be defined as follows. Let x be the random variable representing the number of tails obtained in 3 coin tosses. The random variable, which is x, tail of a coin, we may assign the values of 1, 2, 3, and 4. So our sample spaces, if a fair coin is tossed 3 times, will be H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, ano po ba? TTH, and TTD. Sorry. TTT. These are all our sample spaces. And using this formula, we can calculate the probability for the different values of x. So as we said before, we may assign values 2, 1, 2, 3, and 4. So let's be x is equals to 1, which will signify 3 head coins. If we will get 3 heads if we toss the coin 3 times. We have a probability of 1/8, as we have a sample space of 1, 2, 3, 4, 5, 6, 7, 8. And then we have a p of x is equals to 2, which can signify the number of heads, of 2 heads appearing. So we have 1, 2, and 3. We have 3 possible outcomes where 2h will be appearing. So 3/8. Then we have another. Px is equals to 3 where, bakit may? Where we are looking for the outcome where there is 2 tails. So 2 here, 2 here, then 2 here. So we have 3 possible outcomes out of 8. And then we'll be looking for the last one, which is this one. We have 1 possible outcome out of 8. So all of these are the possible outcomes that we may have in tossing a coin 3 times. But what we are looking for is the number of times the probability of a coin 3 times toss where 2 tails will appear. And as we signified here, where 2 tails appeared, we can see that there are 3 chances out of 8 where the tail appears. So let's see here. Here is a more clear. This is a more clear view. So as we're looking for, let's take a shortcut now. So as we're looking for where 2 tails will appear if a fair coin is tossed 3 times, right? So if a coin is tossed 3 times, we have 4 probable events that will happen. This is where all H's will appear and then all T's will appear. All of those have a probability of 1 only. And there is also a probability where 2 heads appears, and then 2 tails appears. So as we can see here, where 2 tail appears, we have 3 we have 3 possible events where it can occur. So our percentage or the probability of it occurring is 3/8. So that is all of the example. I hope that you've learned something. If you didn't understand, you can go back again to the video and just review some notes. Here, now, if you're confident with your skill, it's now your turn. Try the next 3 questions that I will be posting. It will also be 3 worded problems. So here you go. So the first question is, if a coin is flipped twice, let X be the number of heads. What is the probability that exactly one head is flipped? Number 2, a deck of cards contains 52 cards, of which 12 are face cards, where it is Jack, Queens, and Kings. A card is drawn from the deck. Let X be the number of face cards drawn. What is the probability that a face card is drawn? And then we have number 3. A K-pop album has 7 songs, including 3 ballads and 4 dance tracks. If a fan randomly selects a song to listen to, what is the probability that they chose a ballad? So we will answer this in a more simple way. So take your time to answering these questions. You may pause the video if you didn't get it, and I will give you time. So here. So our first question is, a coin is flipped twice. Let X be the number of heads. What is the probability that exactly one head is flipped? So let's discard this, to be honest, and just go on with the problem. So a coin is flipped twice, and our sample spaces for this will be, there are 4 probable outcomes. Either we get 2 heads, 2 tails, or a head on the first flip and a tail on the second flip, and that tail on the first flip and a head on a second flip. So we have 4 sample spaces. That will be what is on the bottom. And we're looking for the probability of it happening. So we have 4 events. So that will be 4 events, right? And in this event, there will be exactly one. There are 2 probable outcomes where one head is present. So 2. So our outcome, or the probability of exactly one head is seen in these 2 flipped, is 2/4, or if we simplify, 1/2. So we will have a probability of 1/2 of 50% of getting exactly one head flipped. So next, a deck of cards contains 52 cards, of which 12 are face cards. Jack, Queens, Kings. A card is drawn from the deck. Let X be the number of face cards drawn. What is the probability that a face card is drawn? So, as we've said here, there are 52 cards in total, so 52 possible events. And 52 possible cards that we can get. But what we are looking for is the possible outcome where we get a face card. And there are 12 face cards, which means that there are 12 possible events that will happen where we get a face card. So this is the probability of us getting a face card into a deck of cards containing 52 cards. It is 12 over 52, or 20, there are 23 or 0.23 decimals, or we have 23% of getting a face card in a 52 deck of cards if we were to pick randomly. So next we have a K-pop album has 7 songs, including 3 ballads and 4 dance tracks. If a fan randomly selects a song to listen to, what is the probability that they choose a ballad? So again, this is easy. Since there are 7 songs, our possible events will be 7, right? And what we are looking for exactly is the probability of us getting a ballad. So how many ballad songs are there? 3. So we have 3 over 7% as 3 over 7 3 of 7 chances of getting a ballad over the dance tracks, or we have a 42% of getting it. So that is all, everyone. Here is the 43% since we've 43%. So here is the answers to summarize. A coin is flipped twice. Let X be the number of heads. What is the probability that exactly one head is flipped? There are 4 possible outcomes when a coin is flipped twice. There is 2 heads, a head and a tail and a head, and 2 heads. Only one of these outcomes has exactly 1 head. Therefore, the probability of flipping exactly 1 head is 1 over 2, or 1/2. And next we have a deck of cards containing 52 cards, of which 12 are face cards, the jacks, kings, and queens. A card is drawn from the deck. Let X be the number of face cards drawn. What is the probability that a face card is drawn? There are 12 face cards from a 40 non-face cards in the deck. Therefore, the probability of us drawing a face card is 12 over 52. 12 of 52 chance, or 3 over 13. Again, and next we have the number 3. A K-pop album has 7 songs, including 3 ballads and 4 dance tracks. If a fan randomly selects a song to listen to, what is the probability that they choose a ballad? There are 7 songs, and the event of choosing a ballad consists of 3 of those songs. Thus, the probability of selecting a ballad is 3 over 7. Therefore, the probability of a fan selecting a ballad from the album is 3 over 7, or 43%. So that is all, everyone, and I hope that you've learned something today. And our quote for today is, the only way to learn mathematics is to do mathematics. Or in other words, for us to do something, we need to try and do it for ourselves for us to learn it. We just don't learn something in a snap. So we just need to practice and try hard for us to learn that sort of thing. And that applies to mathematics as well. That is all, everyone. I hope that you've learned something from this video. I hope that you've learned what probability mass function is and everything that comes with it. And remember to practice the quote that is posted here for today. The quote of the day, that the only way to learn math is to do math. So don't be afraid to solve equations from here and there to actually learn what you are trying to do. So that is all for today. Again, I hope that you've learned something and you have a wonderful day. Bye!